All right, guys. So Tad Hussey from KIS Organics. Here we go, guys.
You don't have to clap, really. It's okay. Well, if you're here today, my guess is you've grown a lot of plants and you're passionate about cultivation. And I know I've personally tried just about every method under the sun to grow a plant. And I want to acknowledge that there's a million ways to grow a plant. So I really want to start with that caveat. But what I'd like to cover today is twofold. In the first part of my talk, I'd like to discuss marketing claims and how to evaluate a product for your garden. And then in the second part, what I want to pitch to you today is what I think is the most cost-effective, sustainable, and efficient methodology for growing cannabis in controlled environments. And I want to do it in a scientific, data-driven manner. And before I say anything else, I just want to say that if I offend anyone with anything that I say, my wife always tells me that I'm wrong all the time. So I'm entirely open to having a thoughtful discussion about it. But I'm also willing to give you my reasoning for why I believe what I do. But I'm always open to change my mind and hearing what other people have to say too. So let me just start off with a quick story. So the year was 2007. I had just finished grad school and had come back from Australia to help out with the family business. My parents had sold their nursery and landscaping company. I was having trouble finding a job in my field, which at the time was special education. And my father had gotten really into compost teas. He was one of the first soil food web advisors, the first people to take Dr. Ingham's classes. He worked directly with her in determining things like brew length. Could E. coli survive the brew cycle and optimal mesh sizes for brewing? He founded the International Compost Tea Council and was the president of that for a few years while that was around. Now, frankly, it wasn't something that I personally was all that interested in at the time, but I was having trouble finding a job, and I love the idea of science, and soil microbiology was really interesting to me. So I started doing all the microscope work for our company. I started looking at how different inputs, oxygen levels, and brewing lengths affected the diversity and biomass in the teas. That's my father there, taken a couple years ago. Here's an example of our soil under the microscope. You got a lot of great microscopy already from Keisha and those guys. This is the sort of biodiversity that I would just expect to find in a living soil. You can find the full complement of bacteria, archaea, fungi, protozoa, ciliates, nematodes. All those things are going to exist in your soil. But one of the things that I noticed right away was when I would go to trade shows, I'd try and keep a tea going that whole time, and I'd have a microscope set up, and I'd talk to people like at the Flower and Garden Show. And it was really difficult. If you brewed longer than 40 hours, you lost a lot of that biodiversity that you started with. I use the analogy of, what if you went to the zoo and opened up all of the gates at the zoo? Well, in about a week, you'd be left with maybe just lions and rats. You'd have your apex predator and your most efficient scavenger, and everything else would kind of disappear. And we saw that with compost teas. The same sort of thing here. Here's an example of a tea that went way too long, and all we see is just one morphology of either flagellates or ciliates and one morphology of bacteria surviving. And during this time, there was another company marketing, selling compost tea brewers, and they claimed that you could brew the tea, throw it in the fridge, sell it for up to a week for 1,000% profit, and that was their marketing to hydro shops. And so I reached out to them because I felt really passionate at the time that as an industry, if we wanted to survive as a technology, as a viable option for growers, we had to all be on the same page. We had to be putting out good information. And so I just asked them, hey, take a microscope, replicate this experiment. Have you looked at your tea after a week in the fridge, to know that it's viable? And basically what they told me was, they're like, Tad, look, your microbes are the bench players because we have a vortex. The water's swirling like it would in nature with eddies and currents. We're potentizing that water. We're using biodynamic compost. Our microbes are the all-star point guards of the microbial world. Yours are merely the bench players. And I was like, how do I even have a discussion around that or begin to argue about that? But it got me thinking, how much of what I see in garden centers and in hydro shops and online is really marketing hype, and how much of it is really all that true? So I remember feeling totally overwhelmed the first time I walked into a hydro shop. It was so disconnected from what I was used to as someone who grew up with my parents owning a nursery landscaping business and walking into a garden center. What the heck is, Cushy Kush and Cool Bloom and all of these other bottles? You don't have anything like that. And if you ask any grower around that time period, remember this is like 2007, if they were willing to share, and that was a big if, they would tell you that you had to have product X in your regimen if you wanted to grow, the best plants. And so I myself went out and talked to different growers, and I got all of these products. I put them all in my garden at once, and needless to say, I had a pretty mediocre plants at best by putting all these must-have products into my garden. And so I had this weird sort of juxtaposition going on in my head between what I was learning regarding plant and microbe interactions and then all of these like secret sauce formulations that were popping up all around the industry and what I was finding in hydro shops. And it really wasn't adding up for me. So when I started digging into this further, I found that things were not what they seemed. I began looking at ingredient lists and labels and guaranteed analysis and also what's available outside of the cannabis world. What are they doing in horticulture? What are they doing in agriculture? That sort of thing. So I want to take you on just a quick journey and attempt to research just a single product. And let me just say that you all know this company. I'm not going to name them, but they're very well known in the industry. So this was actually from a couple years ago, this slide. They've changed their website. I checked last night to see if it was still there. It's actually gone now. But you see this like professional and scientific looking chart showing some pretty massive increases by using this product. There's no reference to the actual report or study other than this chart. And I didn't cut anything off when I cut and pasted this from the website. This was a standalone thing. Any guesses as to what this product might be? Not the name of it, but what the main ingredient is. We got one in the back. Well, I'll get a little further into it here. So basically, the product's a potassium silicate product. The name brand is really totally irrelevant to my talk. When I take a look at the label, it claims to be potassium silicate, 0.4% potassium, 0.15% silicon dioxide. That's really all we can take away from what we're learning on the label here. On the website, they claim that only Grandmaster growers can use the product, and it's the most effective and concentrated silica product on the market. Gary from Memphis here, he's a master photographer. He talks about how important it is in his grow. So you get testimonials and things like that on the website as well. So I thought I'd reach out to the company and find out if they could tell me a little bit more about what this product was, asking them if they could share or disclose the actual report that created that graph. What I got back was that the graph that they reference is riddled with proprietary information, it's confidential, and so there was no way to verify anything that they showed on the chart. So even though it looked very scientific, there was no way I could have just made a bar graph myself at home and recreated that essentially for how much information they're giving me about this product. So what other information is publicly available? What can we find as a consumer, as a buyer, is in terms of what I'm putting into my garden? So OMRI, the CDFA, the WSDA, they're all going to require some level of heavy metal analysis, some sort of guaranteed analysis. So if something is going on your label that is an NPK, nitrogen, phosphorus, potassium, then you have to submit to the regulatory body a test showing that you have at least those minimum values on the product itself. So if a product's 555, they have to have a test that show they have at least 5% nitrogen, phosphorus, and potassium in the product. If I'm guaranteeing calcium, I have to have a calcium value on there. So you can get some information. Again, this is all submitted from the manufacturer. And you can also look at heavy metals too. So when you go on the WSDA website, you can see what the manufacturer submitted for the heavy metal levels of their product. And I'll tell you, we put a lot of trust in companies, and I'm here to tell you as someone who owns a company, we probably need to stop doing that so much. One company, for example, probably the largest in the organic living soil game, has a test on the WSDA website that's about 40 times the levels of arsenic in terms of what they submitted to the WSDA versus what they're showing on their Instagram every day in terms of transparency. So at the end of the day, you're the one that's going to be on the hook if you don't do any independent testing, not the company. So keep that in mind. And in addition to that, I went on the Oregon Department of Ag website. I looked up that particular company from the original product, the potassium silicate product, and they had numerous violations for adulterated or mislabeled products. And you can see the levels of fines. If you're doing millions of dollars in sales, these $600 here, $1,000 here, it really isn't going to be a deterrent. So the regulatory bodies are not strong enough in terms of what they're doing, and they're not doing enough rigorous testing to really tell us enough about what's in these products. But getting back to my original example, all we really know is it's potassium silicate, right? What I can tell you, just as someone who knows a little bit about potassium silicate, is that most of it is sourced from a single source called the PQ Corporation. They make a lot of this for the industry. A lot of people that are making potassium silicate or silicate-based products are sourcing it from them, adding water to it, and then selling it to you with a brand name and a sticker on it. So if you were to buy a pound of Agsil 16H, and there's a lot of people that sell it, it's not unique to me, I don't manufacture it, I'm not the only one that carries it, you're looking anywhere from like $5 to $20 a pound, and you can make up a gallon of your own liquid silicate concentrate to higher levels than what's claimed in this original product X. So just by doing a little bit of research, you can save yourself a lot of money. You're not paying for a brand name to essentially do that for you. Just to further complicate things though, even guaranteed analysis on NPK values on products can't necessarily be trusted. I just pulled one example off the Oregon Department of Ag website. This is all public information. And they list, here's a product that's supposed to be 0,1816 that they found less than 1% of P and K in. So you just paid all this money for a bottle of nutrient that doesn't really have any nutrients in it. And we've been looking at fertilizers so far, but you may wonder about biostimulants. And I use biostimulants to talk about anything that has biology in it or is associated with biology. Well, there's even less regulation associated and testing with biostimulants than there is with fertilizers. Not to mention how storage and shelf life can impact biological products too. So how do you ever hope to evaluate a product and decide if it's worth using in your garden? Let's say you get through all of these steps with flying colors. You're still interested in the product. We've thrown out testimonials, side-by-side photos, fake graphs, anecdotal claims, all of that stuff. And let's also realize that like word-of-mouth recommendations are wonderful, but at the end of the day, you don't know if that grower used any controls when they first ran that product. I can't tell you how many times I've seen growers go to trade shows, get samples from every company, and then put them all into their garden at once. And if that grow does better than the grow previously, then they feel like they have to do all those same things again. And it's just such a waste of money. So it's something to think about when you're adding a product to your garden. And just to be clear, like my example today with this potassium silicate product is like very blatant. Most marketing is much more subtle. You'll see, videos of healthy plants online. You'll see products tagged in them. Even with my company, we do this. And so you start to make a subconscious association between, a nice-looking flower and that company brand. And that's a great way for people to market to the cannabis industry these days. So. And keep in mind, not all these products are bad. You just may be spending more money than you need to achieve a healthy crop. And that's really all I want to get at today. So how do we really evaluate something in our garden? And this is not just product-based. This is any input, any change, anything that we do. So I just want to talk briefly about scientific method. The very first step that we want to consider, I'll put up the first three here, is make observations. These can be qualitative or they can be quantitative. If we're talking about a qualitative thing, it's subjective. It'd be something like leaf color on a plant or a term like vigor. And that's something that you're going to kind of measure yourself internally. But if we want to do quantitative analysis, then we could do a precise measurement of a variable, something like growth over time or leaf size or wet biomass weight. Those would be all numbers that we can actually quantify and use cycle after cycle to compare what changes are happening in our garden. And the next step is to formulate a hypothesis. In this case, we could say that whatever product that I want to try or any sort of production method in my current methodology will increase dry bud weight or resistance to a pathogen or reduce populations of a certain pest. Whatever that goal is in mind when I'm setting up my hypothesis is really important. And then if you are using a product, please test using a third-party lab. I'll give you some resources at the end of this talk that are very affordable. It's well worth it, and I think really important. Ultimately, you're the one on the hook if your crop fails for heavy metals. You can go back to the manufacturer and complain, but unless you want a lawsuit, they're probably not going to be liable, and they can probably come up with a reason why you failed that wasn't one specific product. Because with things, especially with heavy metals, it's usually numerous inputs, and we can usually narrow that down to one big input through that process, and heavy metals is probably a whole talk by itself, but it's just so much easier to test ahead of time, because if we can keep the removal rate of heavy metals from your soil at a level that's going to pass, a threshold that's going to pass regulatory concerns in your given state, yet pull heavy metals out, and as long as our input rate is lower than that removal rate, we're going to be just fine. So that's really what it comes down to. And then I want to design and perform an experiment. And this is where you use systematic observations, measurements under controlled conditions where only one variable is changing. And that's the most important part. Too many times we see hidden confounding variables where people, maybe they want to change their lighting, or maybe they had one of their growers change the CO2 levels without talking to you, or they had a flood event, or they had a dark cycle because a timer went out. All of those things are going to impact your results. And so you really have to narrow that down and just have one variable changing during that cycle to really know what you're getting. And then we want to accept and modify our hypothesis. So here's where you decide if that variable had a positive or negative or really no statistical effect at all on your crop. And then if you can decide if it bears further research or not. And then replicate your results. You can get your buddy to do the same experiment in his grow. That's even better. If you can do it cycle after cycle, then we can get some more data to just support the conclusions that you're drawing about your given crop or your given experiment. And step 6, dig deeper into results. This is where I think a lot of growers stop too soon. So what if product X leads to a dramatic increase in yield in your garden? Well, let's say product X has 5% magnesium and your plant's magnesium deficient. Well, that in and of itself is going to be the reason that magnesium might have been a limiting factor in your growth. Now you're closer to sufficiency for that element, and so your plant's going to look a lot better. Well, could you use Epsom salt as an alternative, or K-Mag, or some other magnesium source that's a heck of a lot cheaper than buying a bottled product or a brand name product to achieve the same results? And this is where it just requires you to dig deeper into figuring out what your limiting factor of growth is. And as a grower, I can't tell you how many times I've been wrong about hypotheses that I've made about things happening in my garden. Okay, but moving on from marketing and getting back to sort of my journey in the industry and leading to this methodology that I want to talk about. It's now 2008. We moved on a year. I met a guy by the name of Jaya Palmer. And he stopped by my place one day to pick up compost tea supplies. I was literally mixing soil in my parents' driveway, working out of their garage at the time. That was where we started KIS Organics. And I just gave him some soil to take home. And he'd been running Botanicare, the organic Botanicare line at the time. And he found that the soil, just by adding water, was outperforming his current setup in his grow. And so he came back to me. Really, he's a very excitable, charismatic, but scientific-minded guy. He's kind of like that hype man that everyone needs. And he began running trials with the soil and experimenting with different size containers. How quickly could we create a canopy? And we began looking at how we could reuse the media. For anyone who grew during the black market days, you remember how sketchy was it trying to move soil in and out of your house? It was the worst thing ever. You try and do it in the middle of the night, it's heavy, you're stressed. If we could figure out a way to reuse that media, to keep it in place, it would reduce risk so much, it would save on labor, get rid of disposal concerns. It had all these benefits. So that was something that we were really passionate about trying to figure out. And then around the same time, I sat down on a meeting for a really ambitious project in Eastern Washington. And they brought me in, and they also brought in a grower at the time as a consultant who was running I think it was a 200 or 400 light medical grow in Seattle. And it was Nathan Gibbs, this gentleman here, who had a medical grow under the name of Gold Leaf Gardens. And then they transitioned into the 502 rec market in Washington State. But it was through meeting Nate that I was able to start working with a commercial facility and really dialing in some of these methods and getting more and more evidence to support the way that we were trying to grow cannabis. Oh, and just as an aside, when I met Nate, he had this feeding chart that was the most insane thing. And I know other growers have these too, because it'd be like, on Tuesday, you do 5 milliliters of this Botanica product, and then like 6 milliliters of this product from another company, and it was like this giant list that he created his own, essentially his own nutrient line that was so complicated and so expensive. So we were really excited to try to just simplify that whole process. Here's a photo that he sent me from probably around 2008. And this was essentially both of our soils, with the only difference being the addition of 8% biochar by volume. So it really got me interested in biochar. And that was something that I, at the time, really wasn't that knowledgeable about or all that excited about. But this photo really got me excited about learning more about how biochar works and if it was something that would be beneficial in our soil mixes. So fast forward to 2011, while all this was going on, my parents and I decided to open a 7-acre farm and feed store on the property where they used to own a nursery. We had an organic hydro shop. We had an outdoor preschool on the property. We were growing a ton of vegetables. And I was able to see, with my plants there, like I'd have, in 1 gallon, I would have a mulberry tree, for example, that I'm selling in my nursery. Well, I'd take that same mulberry and I'd plant it in the ground. And I could see over the course of the season how much larger that mulberry in the ground grew, just because root space wasn't a limiting factor of growth. Watering was so much easier for that plant because it had access to more soil mass. So I was starting to see some of these practices live out, and running semi-production market greenhouse, growing edibles was also a big part of that too. And so I was learning a lot about growing plants at this time. And this is where we're getting more and more to like some of the anecdotal evidence to support reusing the media. We began experimenting with pots versus beds and diving into soil testing. This was an experiment we ran with the local horticulture college, looking at trialing some recipes for our soils at the time. Not everything goes as well as you want. This was me experimenting with Steve Solomon's Complete Organic Fertilizer and talking to him via email while these trials were going on. And then the addition of biochar to the COF to see if that made a difference. And that's not to say that Steve's recipe is bad. It's really designed around nutrient density, not necessarily like overall yield or biomass growth. And so I think that was part of it. And I also think we didn't really experiment with a lot of different rates. So it's entirely possible we had the application rate on this. But in this trial, it didn't do particularly well. And then there was another I don't even remember what GrowCo was. I think it was another local compost soil company at the time that they were using as a control that just didn't really do that well. All right, so fast forward to 2018 now. That's when I met Dr. Ben Higgins, who's here today. He's going to talk next. And also set up some of the more rigorous experiments at Goldleaf that let us really dial in our methodology and get the data to actually support why we were doing the things we were and some of the evidence we wanted. So I'd like to share just really briefly some of that data today here. So this first one is talking about looking at growing in pots versus containers. So Ben set up this experiment in 30-gallon pots and then a bunch of plants in a bed. I'll just fast forward to the photo. And you can just go on the website and look at the whole study. So it's real easy if you want to read the whole thing. There's a lot more graphs, photos, everything like that. Here's the pots set up here. The plants actually had access to more soil by volume per plant in the isolated containers than in the bed itself. But in the bed itself, I think the reason it did so much better is because, again, root space is not a limiting factor. It had access to more soil volume overall per plant, even though there are other roots and other plants in there. And then, we can get into the whole idea of microbes and plant interactions and how plants, speak to each other, and some of the stuff that Ben's going to talk about and that other speakers have already kind of covered that could explain why we saw such a dramatic difference in overall biomass creation in the beds versus the pots. And the beds had the added advantage of the fact that we didn't have to take that soil then from a small pot, dump it out, remix it, add fertility, and then put it back into the system. We could just re-amend the bed right there in place, and 24 to 36 hours later, we're bringing in our next flower crop. So we didn't have any downtime either there. which saved a lot of labor. The next thing we looked at was irrigation. So as many of you know, watering plays a huge role in your garden. It's one of the things that I think is underappreciated by growers, and it creates a lot of the fertility issues that we see today in gardens. Overwatering or underwatering causes the same plant issue, which is root hair death. And when we get root hair death, the plant's not able to cycle nutrients or uptake nutrients as effectively. And overwatering also can lead to a variety of fungal diseases. So Ben set up a trial comparing hand watering to blue mat irrigation. And the reason we did that was because hand watering was the control, because that was the standard of what they've been doing for years in the facility. And we were trying to make a decision of, is it worth switching to another form of irrigation? How is that going to impact our plants? And so setting up these trials is a great way to check things out in your own facility or in your own garden. So here's a photo of the blue mat setup right here. And these were the results. As you can see, for the most part, there was one cultivar that did not seem to do as well as everyone else, but all the other ones showed an increase in yield by switching irrigation methods. So not only was this saving time for this facility in terms of the hours that they in particular were watering, but they were able to also get better yields out of it. And when you look at the graph, which is on the website, of the differences in variation created in moisture content in that soil, it's much greater by hand watering. And we talk about, like, what if the plant is thirsty at 2 o'clock in the morning on a Saturday? Well, there's no one there to water it. Or how do you account for all the different growth cycles of a plant in terms of how much water it needs based on how much root mass it's created, or what kind of metabolic processes are going on in the plant at the time? So taking the watering out of the control of people, even though these were good growers and these were fairly sophisticated waterers, we got better results using the blue mats. And then the last thing we looked at was Mammoth P as a biological supplement. And this is not a Mammoth P ad either. There's some other biostimulants I'm really excited to start doing some trials with as well. But in this one, my hypothesis was that we would not see any statistically significant difference because we had so much biomass and biodiversity already in our soils. Like I showed you that microscope video at the beginning of the talk. I didn't really think it was going to have any effect, but yet we did see an increase in yield, wet weight yield, by using Mammoth P in the garden. So then it comes a matter of looking at the cost of application and the yield metrics and deciding if it's worth adding to the garden or not. And after that, the next step in that process for me would be like, okay, could we brew this product as a way of increasing the microbial content so we're not having to pay so much for the bottle itself? Or what kind of microbial persistence are we getting in the soil? So could we change our application rates to potentially get these results with much fewer applications and save money? So there's a lot more experimentation, even just with one trial like this, in terms of figuring out what's best for you or your garden. Now, probably our biggest investment in time and energy was into soil testing. And when we started this process, there was no sufficiency or fertility targets really for cannabis that we could find. And I'd started reading Steve Solomon's book, The Intelligent Gardener. It's a great introduction to kind of understanding soil testing. When it came out, it got me thinking about soil fertility from a mineral perspective and how to optimize levels for plant health and yields. Because when I think about living soils, it comes down to three things. And Bill already showed this slide with a Venn diagram, which is probably better than my triangle. But when I'm thinking about specifically about a soil, whether it's actual soil or a soilless media or what we're calling living soil or super soils, the first thing I look at is the physical properties of the soil. What kind of porosity, what kind of water holding capacity, what kind of compaction do I have in that soil? Are the roots going to be able to penetrate effectively? What kind of gas exchange am I going to get? All of those things are really important when we're thinking about the physical properties of the soil. If those aren't right, then the microbes aren't going to be happy, the nutrients aren't going to be available, we're going to have a lot of issues. So I always start there. And then we can talk about the biological properties of the soil. Like I started in the Soil Food Web camp because of my father. And that sort of camp is the idea is that if you get the microbes right, or if you're having a fertility issue, it's because you don't have the right microbes in place. If you're having a disease problem, it's because you don't have the right microbes in place protecting the plant. And that was sort of where I started in the industry, but I was having trouble making actionable decisions based off that information. And what sort of solidified it for me was when I went to San Diego to the International Soil Scientists Society of America conference. It's a mouthful. They wanted someone to speak about cannabis and how it might relate to soil scientists. And fortunately, someone mentioned me and I got the opportunity to do it. I was horribly underqualified to be speaking to anyone in the room, but it was a lot of fun. But I got to go to all these other talks, and a lot of them were grad students and people presenting research. And one of the researchers was looking at fungal to bacterial ratios in soils. So I immediately clued in on this talk, and I went there. And basically what the findings were those levels are changing so dramatically because these microbes are able to reproduce so quickly. And Ben's going to talk about this in more detail. But just hydrology, like a watering event, whether you're watering your plants with a sprinkler, because this was agriculture, or if there was a heavy rain, was going to dramatically impact the microbial composition of the soil. So that got me thinking, how do I use that information then, knowing that it's fluctuating so much, to really make an actionable decision about my garden? And at the end of the day, being that I kind of came from that sort of camp, I was already going to be doing things from a regenerative practices. I wasn't going to be necessarily tilling my soil in most cases. I wasn't going to be adding a lot of fungicides or treating the soil in a conventional manner. I probably adding compost if I'm outdoors at the end of a cycle. So a lot of these things are things I'm going to do anyway. So for me, where I could make actionable decisions in my garden really fell to that other part of the triangle, which was the chemical properties of the soil. And this is where we get into soil testing. Bill covered this all much better than I can, so I'm not going to spend a lot of time on it. But there's a couple things that I do want to highlight here. Agronomically, potting soils or soilless media is very different than actual soil. And Steve Cantwell explained this very well yesterday. When we're talking about actual soil, we're talking about sand, silt, and clay. We're talking about particle size, and it has very different properties than what we're using in cannabis. With living soils, what we're using is probably a combination of compost, earthworm castings, peat moss, cocoa coir, wood fiber, all of these other ingredients that don't act like soil. So we have to keep that in mind. Here's just an example I was doing of trying to show an idea of good moisture content if you don't have a meter or a way to measure it any other way just by picking it up. It was just a video I made a long time ago. But you can see that it doesn't even look like real soil. And Bill described cation exchange capacity. So cation exchange capacity is sort of the soil's ability to retain nutrients, cations specifically. But when we look at this, actual soil has cation exchange capacity, but the organic matter that we're getting in these engineered media or soilless media or living soils doesn't have that. We don't have cation exchange capacity. So that number is on this test here is a little bit erroneous. It's really more a closer idea of your soluble salt levels, because what it's telling you is you have sort of this organic soup of cations and anions rather than these things bound to soil colloids. So that's something important to realize when we're looking at these tests. And, Bill already went over this test really well. I really like Logan. We've been using him for years. Whatever lab you go with, stay with that lab. I can't take a lab from Brookside and compare it to a Logan test and assume I can make good decisions based on the differences in that information. So pick a lab and stay with it. We went with Logan because of Steve Solomon's book, like a lot of people. And we've been really happy with the results there. And there's some things, if I'm looking at potting soil or living soil, that I can't use the same way that I would if knowing this was actual soil. So again, organic matter is going to perform very differently. Bill talked about how nitrogen availability is very different in potting soil. We're not going to get that nitrogen release from the organic matter that we would get from actual soil. And so on this test, for example, the things that I like to look at right away is pH. I believe that pH absolutely matters in living soils. Yes, microbes have the ability to buffer the rhizosphere. That's 100% true. But if we can optimize pH for your plant in the rhizosphere, what that's going to do, it's going to make the plant work a lot less and a lot more efficiently to get the nutrients that it needs. So I aim for a pH target a little bit higher than what Bill was saying. You know, he was, I think, 6 to 6.5 or 6.3 to 6.5. I'm more like 6.8 and maybe even 7. And I don't really freak out until I see like 7.3 to 7.5 because I've seen healthy plants in soil tests at those levels. And we use, I think the incorporation of biochar, which is alkaline, will also push up our pH. We're using a lot of cations, which pushes up our pH. But really your plant is your guide here. So just because your numbers don't fall into my targets or into Bill's targets, if you're able to do tissue testing to see what's actually accumulating in your plant tissue, that's great. But if not, if your plant visually is not showing any stress at that level, maybe it's not as concerning as hitting a target. So the soil test is just another tool. I say like a rake or a shovel or a fertilizer, all of those things are tools. So it's something that allows you to make better decisions in your garden, but it's not the only thing you should be using to make a decision in your garden. Like, for example, I'll go as high as 1,500 on soluble salts. Bill likes to stay under 1,000. Well, I know in my soils at 1,500, I'm still going to be okay. I'm not going to see that osmotic stress that you may see, and because Bill looks at pretty much every soil mix under the sun. He's getting all these tests. He doesn't have as much information as I may have about what's going into my particular soil or from talking to the grower, because once we have a soil test and we've had a conversation with the grower, there's a lot more that's going into a recommendation a lot of times than just the test alone. So I like to know, if possible, I like to see photos of the flower. I like to see a video of the facility. I like to hop on a call with the grower. I want to know what PPFD canopy is, VPD, pest pressure, water test. Are you doing any other T's or inputs? I can't tell you how many times this has happened where I'll get a test back and nitrates have shot up, or available phosphates are super high. And I'm like, okay, what'd you do? And they're like, we didn't do anything but water this whole cycle. And I have to go back to them like, this test is showing me that you had to have done something. There's no way these numbers can go up without you having done something. And then the guy will be like, oh, I just talked to another, one of our cultivators, and they were applying fish hydrolysate, which would explain the higher P from the phosphoric acid. Or, we were doing a bunch of these teas or ferments, and I'm not saying those are bad. They're just a variable that needs to be accounted for. And so we'd see nitrates sometimes 3 or 4 times higher than what we were targeting. So you want to take as much into account as possible. I was on a call last week with a grower that was dealing with really unique conditions in Montana because they had a greenhouse that they were heating really hot, but they were like minus 40 outside, which was some of the coldest weather they've had to deal with. And so they had this high temp, high humidity LED room that was not performing as well as their greenhouse, not performing as well as their LED greenhouse. They had a couple different soil mixes, and they started pumping in, they had CO2 at over 1,000 from a new CO2 burner. Basically, after about an hour call, we figured out, for one, their plants weren't growing as fast as they wanted because they were overwatering the soil that was in the LED room because it wasn't drying out as quickly. They weren't getting as much growth. So now the plants weren't as close to the light as their par meter. Their par meter was showing 700, which is again a little low for flower, but you can get away with that. But their plants were a foot and a half below that. So they're probably, 500-600 ppfd. So light's now a limiting factor. They're pumping all this CO2 in. The plants aren't liking it. It was a variety of issues creating this problem. So if I had just looked at the soil test, and to be fair, they were low on sufficiency on a number of minerals, but I didn't feel after this conversation that was necessarily the limiting factor of growth. Like, we wanted to address it next cycle, but really, I felt like at the end of the call, like the overwatering and their lighting were probably their biggest problem outside of just shutting off their CO2 burner. When they shut off their CO2 burner, a lot of this weird twisting that they were getting at the top of their bud started to go away too. So it's really this like detective process. And sometimes having someone come in from the outside that hasn't been there every day staring at these plants can be helpful. But at the end of the day, like, I'm not going to be able to diagnose your plants from a photo. And there's no one that can do that, really. I mean, there's things that are characteristic that we can try and guess at, but really it takes a holistic approach to a garden to really know what's going on. So the process that we kind of landed on involves getting a soil test a few weeks out from the end of the cycle, re-amending that with a specific nutrient load to get us back up to sufficiency on those nutrients. We like to mix those into the soil to get those nutrients right back into the rhizosphere. That could be a whole nother conversation as to why we do that. And that's one of the reasons we don't use cover crops, in addition to cover crops indoors potentially being a habitat for pests and pathogens. That's not to say that those things are bad. I know Steve is going to talk about it, and I know he kills it with those things. So again, million ways to grow a plant. This is just what works really well for us. We do sacrifice some things. We know the soil is going to dry out a little faster if we don't use cover crops. We know that we're not going to get the same level of organic matter added to our soils. But in terms of incorporating nutrients, for us, that was more important, to be able to get those nutrients back into the soil where we wanted them in the rhizosphere. So here's a time-lapse video of that process from Mako Farms. This is a good friend of mine. Jaya's actual best friend, Justin, runs this farm, and he sent me this video, and he just kind of shows it. So they are using blue mats. There's about 20 yards of soil, I think, in the entire room. And 2-3 weeks out from harvest, they'll send a test off to Logan Labs. They'll get that test back. It actually gets sent directly to me the way we have it set up. And then we schedule a call with the grower, dialing in sort of the fertility around that soil test, have a conversation about it. And this grow, I can tell you, has battled everything under the sun. I think right now they're still battling root aphids. They had the cannabis aphid for about a year that they were fighting, all with the same soil. And so they stuck it out through the soil. And they also now have some positive hops latent viroid tests as well in this grow. And you can see from the photo, like, you get quite a bit of diversity in expression. And with this method, we're not dialing in every cultivar. We can't. It's impossible. What we're trying to do is make most cultivars as happy as possible and make sure that we're getting the yields and consistency that we want. Because some plants are going to senesce faster than others. Some are going to want a little more magnesium. Some are going to want a little more calcium. We're going to try and do our best to get something general across those beds. And if we have a real issue, we can do a separate targeted soil test for that particular bed, or we can do a virus test to see if there's something going on with that plant. But overall, the amount of biomass and consistency that these guys get cycle after cycle. I mean, this soil is 25, 30 cycles old now. Even with all of those challenges, they're still able to put out really good product cycle after cycle. And just so you know, like, the cost of a test, Logan Labs test, complete test, is $55. We'll do one test for that entire room. You don't have to test every single bed in your facility. If they were all treated the same, I've seen enough where growers have tested every single bed, and then they've done one test of the whole room. That one test of the whole room is generally close enough to what we can see the trends between those beds that you don't have to test every bed. That's a good way to save money too. So they're able to get consistent harvests, allowing them to command top market value for their flower. Here's a video out of Montana. This is Haskell Farm. Craig Haskell is someone we've been working with, and they're actually growing in a vertical system. They are 2 tiers using, they have BIOS LEDs, grassroots pots, and then they've been using our soil now for a few cycles on pip racks. There was actually a lady I met here today who has a 3-tier living soil grow, which I hadn't seen yet, at least not in terms of beds. I know Christina is doing one out in Ohio, I believe, that is like 5 or 6 tiers, but they're in pots. I think due to the weight challenges associated with this method of growing. So it is possible to go vertical. Since this video, Gold Leaf has gone vertical as well. Ben can talk more about that too, potentially, if you guys have questions. But there's no limitations, I guess, in terms of going vertical with living soils now, which is one of the big criticisms, I think, of this methodology. So my final notes or thoughts on all of this is, science is not static. It's not dogmatic. We are constantly learning, adapting, and improving as more research becomes available. There's so many new things that we want to research. There's no reason you can't do your own research and your own grow. And just because something works at Gold Leaf, it works at Mako Farms, you're going to have different challenges in your grow. No two grows are exactly the same. So it's always good to run a trial, even when people come to us and are like, hey, we want to just switch over to living soils. Ben and I are always like, all right, slow down. You've been doing a chemical grow with, Athena and Rockwell or whatever, cocoa. This is a big change. So not only are the plants going to grow completely differently, but all of your SOPs need to change. And so it may not be as smooth a transition as you think. Set up a small trial. Let's run a few beds, a few pots. Let's see if we can match your yields, if we can make your SOPs simpler by switching over to this process. And if we can, then we'll move forward. But always start with the trial, no matter what you're switching to. And then there's a bunch of stuff that we still want to experiment with. Blue Mat has these capillary mats that I'm curious about. I haven't gotten a chance to do any trials with those yet. So that's something that I want to set up a trial on. Steve's idea around bottomless pots, I think, is really ingenious. And I'm really curious to set up a trial at my place to see how they do, because that alone could save so much labor in a commercial facility. Because every time you have to touch a plant, every time you have to do something, that's a lot of labor, that's a lot of time, that's a fail point in your facility. And if we're trying to optimize these things, anything we can do to reduce those things is a win in my book. So there's a lot of new things. There's some new phosphorus boosters that are coming on the market. One of them was developed by a friend of mine, David Bernard Perron's college roommate coming out of Canada that I really want to do some trials with. We're working on some new phosphorus products personally within KIS Organics that are lower in heavy metals that we can confidently say we can get you a clean pea, because phosphorus is one of the hardest ones to get clean, low heavy metal loads on. And I want to do some more work with mycorrhizal fungi. With my podcast, I've had a variety of researchers on, university professors, and it's so funny because it's a very polarizing topic. I started out big fan of mycorrhizal fungus, and then I read a study out of the University of Florida that said that high P and trichoderma inhibit mycorrhizal infection, which got me thinking those are two things that we absolutely have in our living soils for the most part. So it got me thinking, well, maybe we don't want to use mycorrhizal fungus in our gardens. And then I did a podcast with Dr. Yoram Kapulnik out of Israel, who just researches and studies mycorrhizal fungus, and he developed the Dino-Myco product, the particular strains in that product. And he got me really jazzed about mycorrhizal fungus again. And then just a few weeks ago, I was talking to another researcher and a pathologist, and they're like, yeah, we did trials, and we found no infection in our cannabis plants. And so that's not to say that any of these people were wrong, but what I would like to do is do some studies to actually see in living soils, how much benefit we're getting from adding mycorrhizal fungus. Are we getting good infection? How long does that take? What sort of pea uptake are we getting? There's just so many things that we want to study. The list is really long. We just kind of have to prioritize those things, because there's also a ton of stuff I want to do around lighting and airflow and environment and all these other things. So that's the cool thing about cannabis, is we can do this research ourselves, and then we can take it back to the university and say, hey, we're seeing these trends. Can you do a trial to sort of, more definitively replicate and explore this idea? So we're kind of like the citizen scientists in a lot of ways, and the universities really encourage that kind of research because they want to know what to study next. So through the podcast, I've had the opportunity of interviewing and talking to a lot of these researchers, and any way that we can bridge that gap between what's going on in horticulture and the university and what's going on, with you guys and with us in cannabis is a win in my book. And then marketing, it can sound like science. Arguments can be really convincing. You can have beautiful plants everywhere on social media, but you really have to be a detective and dig deeper. And you have to look at what's your limiting factor of growth. I mean, I say that over and over again because it's so important. You really have to be a detective. And because if you can keep figuring out what's, not filling that bucket, what's limiting your plant's overall health and vigor, you can keep improving that plant. But it's a long, long process. I talked about some resources. I'm gonna give myself a plug with this podcast. I'm very grateful to have so many people so much smarter than me come on the podcast and share their research and information. The research that I talked about with Ben Higgins is up on our website, on our blog page, so you can read the whole study and you could replicate it yourself if you wanted in your facility. Logan Labs, we've loved working with them. There's a lot of good soil labs out there. I really like the Malic 3 and the saturated paste as an informational tool. And like I said, I can look at a Logan test so quickly now and figure out the limiting factor of growth. Delta Urban Soils Lab, if you need to do heavy metal testing, they have a process. I did an interview with Dr. Anna Paltseva, who's the head of that lab. I think she charges like $15 a sample, and it's not going to be as accurate as what these other labs are doing, but it's going to give you a rough idea of where you're at on heavy metals. And I think that's good enough for most growers. And we've done this now with all of our amendments that we sell. So on our website, you can click on that test and see what we got back from them. But I still encourage you to do your own testing. Don't take my word for it or the lab tests that we're putting up anymore on that. But you can go on there and see our results as well on our products and any of the like kelp meals and Calphos and azomite and those products that we sell. And then the North Carolina State Research page, Paul Coxon and Patrick Veazey, I've had them on the podcast. They're graduate students. Paul did this paper on the characterization of nutrient disorders in cannabis. It's an open source paper. Anyone can download it. Awesome resource. He's got visualization of all of these deficiencies, what happens when you withhold nitrogen from a plant? What happens if you withhold phosphorus from a cannabis plant? And he'll show you photos of that, of the progression of deficiency or toxicity for all these minerals. So it's a really useful tool. And we also have on our website something similar to that on our blog page. You can take a look, and we link to that right there too, so you can check it out. And then lastly, my next podcast is with Dr. Carrie Peters from J.R. Peters, Jack's Fertilizer. They have a lab as well. They do tissue testing. I think it's around $50 or $60, and she talks about that. That's another resource that's just now becoming available, kind of like SAP testing to cannabis, now that we can actually work with a lot of labs. So I think that's all I had. I really appreciate your time today. Are there any questions? Oh, that was fast.
Tell me who's first, Tad, and I'll run to him.
Dude, it was a race. I have no idea. You can pick. It was like 3 here and then Steve.
I'll go first because it touches in onto what you were saying earlier. I have a big academic background, but I'm not in academia, and I know that scientists often design experiments just looking for one thing. So they might, in order to reduce the complexity of the real world, they might pare down their environment to just include, just like, I don't have an academic, or I don't have an agricultural background, so I can't really give you examples, but if they're just looking at one thing, like I often think that I often wonder, like, how let me put this in a short.
I think I get what you're saying. So
yeah, well, what I was wondering was, how are you seeing are the scientists doing stuff are they changing their experiments to include living soil? Because there's so many variables.
You're right. I get what you're saying. Yeah. So essentially, what you're asking is, are universities at all interested in studying, a methodology like this, or living soils in general?
Are they able to give you actionable information? Like you said, they're trying to find information to
yes and no.
Take action on.
So here's the challenge. Because of the complexity of a living soil bed and all the variability that happens with these microbe interactions, it's not really something that we as humans have the ability to study or quantify effectively. And so it's a variable that as a university researcher, as a scientist, you want to throw out. So they're going to want to grow in rock wool. They want to grow with like specific chemical fertilizers where they can control every aspect of that grow and what results they're going to get. So what we have to do is sort of extrapolate some of that data and then get an overwhelming body of evidence to support why we're doing what we're doing in a living soil facility. And I think people are going to come around, and we may eventually see research, but absolutely that research does not exist because it's the same thing with compost tea. Like every compost tea is going to be different. We don't know everything that's going on in there. I can change the brew length by 4 hours, and I can have a completely different composition of microbes. So how do you study that, and how do you draw conclusions of that, knowing that there's so much variability? And the answer is you really can't. But I think that's okay if we just accept that as our control. So in like, Ben can probably talk about this better than me, but our control is going to be that living soil bed. We're just going to take all of that diversity and nutrient cycling and microbial plant interactions and just say that's our control, and then we're going to see where we go from there. But in terms of like rigorous scientific academic study, they're not going to like that. It's just not rigorous enough, and understandably so.
We got about 4 minutes left here, guys, so we're going to have to do some rapid questions. Oh, Steve's got it. Okay, I'll see you afterwards.
You kind of snuck in a couple big ones talking about the root aphids and the hop Latin viroid. I'm just curious what you guys, one on the hop Latin, said that horribly wrong, that viroid, your opinion on it in the cannabis industry in general, because everybody seems to be really scared about that one. I have my opinion on it back when they used to call it duds. Got through it, just curious your take, and then what are you doing about the root aphids? Because that's something I haven't experienced and I get asked almost every single day.
Great questions. Let me start off by saying I'm not a pathologist and I'm not an entomologist. I'm fortunate to know some that are very, very smart and good at what they do. So in terms of the hops latent viroid, what we're seeing and seems to be echoed in the industry is if you are able to reduce plant stress, you don't get that expression. If the plant gets really stressed, and we hear all this stuff about crop steering, I'm really starting to hate that word, just because it's kind of like the latest buzzword, but when we start stressing a plant, we get more expression of the viroid, it seems like. But we do have positive tests that show that, and here's the other challenge that they've recently discovered is that testing the leaf tissue really is not the best way to find out if your plant has this viroid. Some of the recent research shows that you can have a positive root test, but a negative leaf test. And the leaf test was only about 50% accurate, whereas the roots were much more accurate for testing. But yeah, like you said, like a dud, that's what happens. The plants just crash on you and you don't get the yields that you want. These guys weren't willing to throw out their soil, so they're just pushing through, and they've had it for a while. They just know they're infected. If they ever start over, they'll want to start from scratch and really try and keep these things out of the facility. In terms of root aphids, they have a whole regimen around it. I could email it to you. I don't even know it all fully myself, but I know some of the products that they're using, some of the ones they're not. Root aphids is one of those things that, and Suzanne hates the word eradicate. Suzanne Wainwright Evans, if you're not familiar with her, she's the bug lady. She is the best in the industry when it comes to beneficials and pests and anything entomology related for cannabis crops. She hates the word eradicate because you're never really getting rid of anything. We can say that we haven't seen the cannabis aphid at Mako Farms in over 2 years, which is awesome. But there's always the reality that just by spraying or just by bringing beneficial insects, you're not necessarily going to remove that pest entirely. I know I didn't really answer your root aphid question, but we can absolutely chat about it later. Yeah.
We got time for one more here.
Hi, my question's really similar to his. I've been involved in the hop latent testing program at our company for a couple of years now, and so I'm just curious if you observed like which bed had tested positive and what percentage of plants that you planted into that same bed tested positive after that.
That's a great question. If you email me, I can find out the answer from Justin or Allison, but I don't know it offhand.
Okay.
Yeah, I know they made a decision to keep going with those beds, knowing that they could have essentially a dud pop up in there since they know they have this active viroid in their rooms. But it is what it is. Yeah, and I think some cultivars they found were much more susceptible to expression than others. So they're trying to select for cultivars that are sort of those hype strains, but also give good yields and allow them to be successful. So, yeah.
We got time for maybe one quick one if it's going to be a rapid answer from Tad.
All right.
Steam sterilization, and with the root aphids, would you consider that, or other, like re-inoculating soil? What's your theory about steam sterilization of soil?
I haven't looked into it because we just don't have a viable way of doing it right now ourselves at the facilities that we work with. I suppose if someone had the equipment and wanted to try it out, you could. You're losing a lot of that microbial succession and ecology that's probably helping to reduce some of the expression of these pests and diseases, but I'd just be speculating at this point. I've never actually done it, so I don't know. Yeah. Okay.
All right, guys.
Thank you,
I think
everybody. I
we're-
really appreciate it.